The decision to use Universal Robot's collaborative robot technology was made several years ago. We chose UR as our partner for development in this area. Why? Primarily because the company offers a particularly advanced man-machine interface that goes perfectly with our applications and our requirements. This was an important opportunity for us, because at Mirafiori we have a fairly high average age, and so ergonomics become a key factor, even in simple manual operations. This ensures that line operators work in symbiosis with cobots, ensuring they can concentrate, leaving those involving a greater ergonomic burden to the robots. The primary need for this choice was the fact that there were obstacles in terms of space. Due to the architecture of the structure, that is, the center-to-center distance between the bulges, which are the reliefs on the frame where the panel pushpins can be connected. And at the same time, we had to seal and then align the sealed part. We turned to the cobot for this, because it allowed us to perform a whole series of maneuvers with millimetric precision, guaranteeing the final result. In the area where the soft top of the Cabrio version is mounted, we needed to perform a cleaning operation and activate the track of the primer over which the glue would be applied. And at the same time, we needed everything to be inspected prior to application, to make sure we wouldn't have to rework it all, which would be very difficult and expensive. The second cobot we installed checks the dimensions of the soft top frame and passes on this information to the robot, which then picks up and applies the soft top. We have 4 applications of human-robot collaboration in the glazing business unit, with a total of 7 robots installed and operating on the backbone for production of the electric Fiat 500. On the Cabrio door preparation line, the Universal Robot's collaborative application inserts 10 pop rivets, which connect the hinge reinforcements of the trunk to the trunk structure. The benefits of this type of application are primarily in terms of productivity plus improvement of ergonomics of the workstation. The chassis comes to the station with the hood assembled in the closed vehicle position and the screws of the hinges on the hood tacked by the workers in the station right before it. Once the geometry has been finalized, the robot positions itself over the 4 screws and starts tightening them to the final torque. The benefits of this type of application are ergonomic, in that the hood is tightened closed in the vehicle position. The other benefit is qualitative, because the worker would be unable to see the screws and could potentially fail to tighten them or tighten them incorrectly. With the aid of the advanced tool, we position the door within the reference marks on the chassis and start up the cobot, which goes into the rear part of the door compartment to anchor it inside the chassis. Application of this task offers us 2 alternative solutions to the employee's ergonomic and qualitative problems. One is that he would have to add it on the inside of the chassis without being able to see the spot, and the other is the recoil he would suffer from the motor reaching a torque of 75 Newton. The chassis comes to the screwing station with the right and left fenders already tacked in place. 4 cobots are installed on this advanced piece of machinery. Once the geometry has been determined, the robots move in synchrony, reaching 12 + 12 anchorage screws and tightening them to the appropriate torque. It allowed us to eliminate tensile stress on the sheet metal and achieve anchorage under the chassis ergonomically.